Guys, all right, so how do we find the zeros, aka the roots, the solutions, the x-intercepts of polynomials is the question of the day. We are on lesson 5.2. Your homework will be on page 72, numbers 13 through 19, and we need to figure out how do we find the zeros. And zeros have multiple names. That's why we have up here aka. They're also called the roots of the equation. They're also called the solutions of the equation. They're also called the x-intercepts because on the graph, it's where it crosses the x-axis, okay? So these are many different aliases for the same thing, finding the zeros, okay? So we're going to start with a warm-up. We're going to find the zeros of f of x equals 3x cubed plus 2x squared plus 6x plus 4. So that means since we are finding the zeros, we are solving for x. We're finding the solutions. Okay. All right, so we have some previously learned information here. And that is that when we are solving one of these, we can usually refer to factoring. We just finished 5.1, which was looking at different methods to factor. And factoring is going to be very important in order to solve because most of these we're going to be able to factor and we need to know how to factor in order to solve them because the quadratic formula only works on quadratics and this is not a quadratic. So the degree tells us something else about the polynomial. The degree of the polynomial tells us the max number of zeros. And we've already learned that because we know that if we have a cubic, the maximum number of times that it could cross the x-axis is 3. That doesn't mean it's automatically going to have 3 zeros. It just means that the maximum number of zeros for this function could be a 3. It won't be higher than 3. It'll be 3 or lower, okay? So that gives us an idea of how to narrow things down. It's important to know that. All right, so let's start it off. When we are solving for x, I need to tilt this because I'm a lefty. We change the y or the f of x to a 0 because we're solving. We're trying to find the zeros of the graph where it crosses the x-axis at. That's where the y value is 0. 3x cubed plus 2x squared plus 6x plus 4. Okay, and there are exactly 4 terms. And we learned a new method. It's called factoring by grouping. So if we have an even number of terms, we could try to factor this by breaking it in half and factoring each side. On the left, we have a x squared in common. So when we factor it out, we divide it out, we'll have 3x plus 2 left. Always bring down the sign after the break. It's a plus sign. And on the right, the common factor between 6x and 4 is a 2. Divide out that 2 and we'll have 3x plus 2 left. Hey, when these are the same, that means we're doing it right, and that is one of the factors. So 0 equals 3x plus 2. And then my leftovers, we got to slap them together, and we get x squared plus 2. Okay, so now we can solve. We learned this back in math 2. We can solve using the zero product property. We can break apart these products and set them each equal to 0. And now we have 2 mini equations that we can solve, and it'll be super easy, lemon squeezy. Subtract 2 on both sides, we'll get 3x equals negative 2. Divide both sides by 3, and we'll get x equals negative 2/3. So there's one solution, 1, 0. For the other one, we need to subtract 2 from both sides, and we'll get x squared equals negative 2. We'll take a square root on both sides, and anytime we are solving for x and having to take a square root, that x has a plus or minus version, a positive or a negative version. and we have a negative under that radical. So what does that mean? Well, we learned in Math 2 that means that it turns into an imaginary number. So when I teach it, I tell my students, we got to poke an eye out. So poke an eye out, and the 2 is not a perfect square, so it's stuck inside. So plus or minus I radical 2. So this solution actually breaks down into 2. That plus or minus means that there's 2 solutions there. We have an x equals an I square root of 2 and an x equals a negative I square root of 2. So there's 2 solutions here and 1 solution here for a total of 3 solutions. How cool is that? So it's not bad. So lots of algebra in this section. All right, speaking of algebra, we have the fundamental theorem of algebra. This theorem tells us how many blank a polynomial should have. Well, since we're talking about solving, it probably has to do with how many zeros a polynomial should have. So if we have a polynomial x to the nth power, it's going to have n zeros. So for instance, this one was to the 3rd power, and it had 3 zeros. The problem is only one of these is a real number. These 2 are imaginary numbers. So we would see this one on the graph. This would be where it crosses the x-axis at. But these we wouldn't see because they're imaginary. But they exist. Okay. So zeros can be real or imaginary, like I just said. Okay. Those are called complex numbers. You learned this too back in Math 2. They're in the form a plus bi, where a is the real part and bi is the imaginary part. This is the real number part of the number, and this is the imaginary part of the number. When you put them together, that makes it a complex number because it's complex. It has a real part and an imaginary part. Okay, before we dive in though, we have to remember some things. Okay, we have to remember, number 1, how many zeros. So that means we need to look at the degree of the polynomial to figure out how many zeros we should be looking for. Number 2, the complex conjugate theorem. We learned this back in Math 2. It guarantees that imaginary answers will always occur in pairs. So if we know that one of the solutions is a plus bi, then automatically we know that it comes with an x equals a minus bi. Also, if we know that one of the solutions is x equals 3i, then we know that it has a matching pair, and it also has x equals negative 3i, the plus or minus, okay? These are complex conjugates of each other. These are just the plus or minus, okay? But anything with an I will always come in pairs, the positive one and the negative one, okay? And then step 3, another thing we have to remember, the ways to solve. So we have a couple different things to be looking at. If it's factorable, we have many, many ways to solve a polynomial that is factorable. We can look for common factors. We can do a difference of perfect squares. We can do the easy and hard trinomials. If there's 4 terms, we can factor by grouping, what we learned in the last lesson. And we can also use the quadratic formula. If it's a quadratic, that means it's got to be something squared, an x squared. Okay. We also have, if it's not factorable, how can we solve it if we can't factor it? Or can't use the quadratic formula? Well, we can use graphing, or we can hunt for the zeros with synthetic division, and that will be in the next lesson. So today is mostly going to be focusing on the ones that are factorable. So this is our focus, the factorable ones today. Okay, so don't worry, we'll go hunting for the next lesson. And it's actually a lot of fun hunting. If you like synthetic division, this is actually fun. These are fun too, because I am such an algebra person. I like the logical steps behind things. So I hope you do too, or at least you learn to. A lot of math that makes people hate it is just because there's gaps in their learning and they just don't understand. So hopefully I can fill in those gaps for you, but that means you got to be doing your work on time. You got to be asking questions and do retakes whenever you can, pretty much. All right, examples. We're going to find the zeros by factoring and using the zero product property, just like we did in the first warm-up. We're going to show that the fundamental theorem of algebra is true for each. Okay, so let's look at number 1. First thing I'm looking at is the degree. This is a degree 3, so that means that there should be 3 zeros according to the fundamental theorem of algebra. Okay, well, let's find these zeros. So we're going to have to factor this, and let's see. It's a cubic, but it's not a sum of cubes or difference of cubes, but there is a common factor of an x. So remember, when we're solving, we change the f of x to a 0, and we got to factor out an x because that's the common factor. So it leaves me with an x squared plus 9. I can't factor that anymore, but I can use the zero product property and break these apart and set each one equal to 0. Look at that, we have an answer already. Sorry, my son was screaming in the background. Anyways, this one we got to finish solving, so I got to subtract 9 from both sides. So I get x squared equals -9, and then we're going to need to take a square root on both sides to undo that square. And so x is going to equal, remember, plus or minus. I see a negative under the radical, so we have to poke an I out, and the square root of 9 is 3, so that's a 3i, plus or minus 3i. And this we know is 2 solutions, the positive 3i and then the negative 3i, and then x equals 0 is my third solution. So I do have a total of 3 zeros. So check. Sorry that you guys have to hear a screaming child in the background. Anyways. Next one. Okay, number 2. W of x equals x cubed plus 216. So first of all, how many zeros should we get? We should get 3 of them. Okay, so let's factor this. Now this looks like a sum of 2 perfect cubes because I know that x to the third is x to the third. But what to the third power is 216 is the question. So let's see. Is it 4 to the third? Nope, that's 64. I know 5 to the third is 125. I'm getting closer. Is it 6 to the third? Yup, 216. So 6 to the third power is 216. Okay, so it's a sum of cubes, so I know the formula is going to go plus minus plus. Okay. So let's set the w of x equal to 0 because we're solving for the zeros. We're going to have a plus b, so x plus 6 times a squared, so x squared. Oops, it's supposed to be minus. My bad. Minus x times 6, and then plus 6 squared, which is 36. This is a minus sign. Let me go over it with a different color. Plus, minus, plus. Okay. All right, why am I out of focus? Come on, focus. All right, there we go. Okay, so we know, based on learning this in the last lesson, that this trinomial is not going to be factorable. So we're going to have to use another method to solve it. This one, however, all we got to do is be like x plus 6 equals 0. So x equals -6. All right, we found a solution. So like I was saying before, I can't factor this one. This is not factorable. Don't believe me? Try product sum. It's not going to work. So that means we get to use the QF. What does QF stand for, you ask? The quadratic formula. And anytime I use the quadratic formula, I will sing the quadratic formula. So it is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, you guys remember that, right? Right. I know you do. Nick's probably shaking his head right now. I could just see it. All right, so x equals, you know what? Before we start this, let's identify the ABCs. A is 1, B is at -6, and C is 36. So x equals negative, B is -6, plus or minus the square root of b squared. -6 squared is 36. Minus 4 times a is 1 times c is 36. All over 2 times the a is 1. Okay, I like to take care of double negatives. There's a double negative out here, and that's the only one. So x equals 6 plus or minus the square root of what goes in that square root? Well, 36 minus 4 times 1 times 36. That's basically 36 minus, well, what's 4 times 36? 144. Oops, focus. It's 144 all over 2. Okay, so I have x equals 6 plus or minus, what's 36 minus 144? Negative 108. Okay, all over 2. All right, and now we're going to need to reduce this 108. So we need to look for the biggest perfect square possible that we could find in a 108. Well, let's try 108 divided by 4, because we know 4 is a perfect square. Okay, 4 and 27. So we know 4 works. Off to the side, let me pull out a Post-it. I have these Post-its right here. When you're dealing with a big number, it's kind of helpful to do a factor tree out all the way. So we know 108 divided by 4 is 27. And 27 is 9 times 3. So 4 times 9 times 3 equals 108. And then I'm noticing something. What's 4 times 9? It's 36, Mrs. Garcia. So what if I did it this way? What if I broke down 108 divided by 36? Should I get 3? 108 divided by 3 is 36. So there's my biggest perfect square. I like to do it that way. If you break it down and look for the mini perfect squares throughout, you just have to take the square root of this number, square root of this number, make sure that you multiply their square root answers together on the outside. Okay, but I like finding the biggest one. Right, Nick? So I can break this down to 36 and 2. I know there's multiple Nicks in this class. The one I'm referring to is Nick Watson because he had me last year. All right. So Nicholas Graham, you might be like, what are you talking about? I have no idea. X equals 6 plus or minus. We have to poke an I out because of that negative. And the square root of 36 is 6, so 6i. That 2 is stuck inside all over 2. And when we reduce a radical, or these numbers around the radical, we have to do all or nothing. They all have to have something in common or you can't reduce it at all. They all, the 2, the 6, and the 6, all have a 2 in common. 2 goes into itself once, goes into 6 3 times, goes into 6 3 times. So x is going to equal 3 plus or minus 3i radical 2. I don't need to put the all over 1 part. All right, so here are 2 of my solutions, 3 plus 3i radical 2, and then 3 minus 3i radical 2. And then my third solution is x equals -6. Okay, so I definitely have 3 zeros. So check. Fundamental theorem of algebra verified. All right, number 3. We have k of x equals x cubed plus 5x squared plus 9x plus 45. I see 1, 2, 3, 4 terms. So immediately I want to break it in half and factor each side. So let's change the k of x to 0 because we're solving. The greatest common factor on the left is an x squared. And when we divide that out, we'll have an x plus 5. Bring down the plus. On the right, the greatest common factor is a 9. Divide that out, we'll have an x plus 5. Woohoo! They're the same. So one of the factors is x plus 5. And the other one is the leftovers that we have to slap together. And now we just have to break them apart and set them each equal to 0. So x plus 5 equals 0. X squared plus 9 equals 0. So when I subtract 5, x is going to equal negative 5. There's a solution. When I subtract 9 from both sides, I'll have x squared equals negative 9. Square root both sides to solve for x, and x is going to equal plus or minus, got to poke an eye out, 3i. So there's a total of 3 solutions, and oh, look at that. There should be 3 of them, so there are 3 zeros here. So all of these were to the 3rd power. And then look at number 4. It's not to the 3rd power. It's to the 4th power. So we should be getting 4 zeros here. All right, let's see. So 0 equals. Now this is a difference of 2 perfect squares. What happens to be squared is x squared squared is x to the 4th, and 4 squared is 16. So remember, when it's a difference of squares, it's a plus b, a minus b. So x squared plus 4 and x squared minus 4. Okay, I can keep going. This is not factorable, but the x squared minus 4 is another difference of squares. I can keep factoring. So 0 equals x squared plus 4 times x squared minus 4 factors down to x plus 2, x minus 2. And now I'm done factoring. So now I can break these apart and set each one equal to 0. So x squared plus 4 equals 0. X plus 2 equals 0. And x minus 2 equals 0. Okay. So if I subtract the 4, I'll get x squared equals negative 4. Square root both sides to solve for x, and x equals plus or minus. We have to poke an eye out, and the square root of 4 is 2. So 2i, plus or minus 2i. So there's 2 solutions right here. Subtract 2 from both sides, x equals negative 2. So there's my 3rd solution. Add 2 to both sides, and x equals positive 2. There's my 4th solution. So we have 4 zeros. Fundamental theorem of algebra checked and verified. Turn the page. All right, well, with these problems, we need to be able to go forwards and backwards with them. So that means now we need to be able to have the answers, the solutions, and figure out, well, what polynomial did they come from? So we need to work backwards. So this section is going to teach us how to do that. So we need to write a polynomial function of the nth degree that has the given real or complex roots. So let's look at number 5. We have n equals 3. So that tells me that this is the degree. The degree is 3. Okay, so that means that there should be 3 zeros. I only see 2 zeros here. X equals negative 2 is a real number. So I'm going to label that real. This is a real solution. And I have x equals 3i. This is an imaginary solution. But remember, imaginary numbers always come in pairs. Focus, there it goes. So that means there should be a pair that comes with this. Come in pairs. So if we have a positive 3i, then we also must have an x equals negative 3i. Okay, so there are our 3 zeros, our 3 solutions. Okay, so now let's write them down. We have x equals negative 2. We have x equals 3i. And we have x equals negative 3i. Now let's work backwards. Let's unsolve them. So to unsolve x equals negative 2, we would add the 2 back over. So we would have x plus 2 equals 0. Do the same thing with the x equals 3i. Subtract 3i from both sides, and we would have x minus 3i equals 0. Do the same thing for x equals negative 3i and add it to both sides. We'll have x plus 3i equals 0. So remember, when each of the factors equals 0, that happens after we break them apart and set them each equal to 0. So let's not break them apart. Let's unbreak them apart and put them back together. So that means that I'm going to have a factor of, let me switch colors. We're going to have a factor of x plus 2 times a factor of x minus 3i times a factor of x plus 3i. Okay, so we need to figure out the polynomial, and now we know what to multiply together. So here is the kicker. You always multiply the i's together, and you always multiply them first. Multiply the i's first. Exclamation. Okay, so let's focus on that. So x times x is x squared. X times 3i is a positive 3ix. Negative 3i times x is a negative 3ix. Negative 3i times positive 3i is a negative 9i squared. Okay, so first of all, we have some things that cancel, such as these positive 3ix and negative 3ix. They gone. And this I squared means something. In Math 2, you learned that I squared equals negative 1. So we can replace I squared with a negative 1. And so that's going to make this 9 a positive 9. Okay, so we're going to have x squared plus 9 after we simplify all that. We'll now bring down that x plus 2 factor. And now we can multiply that last factor in, and then we'll be done. So let's multiply it out. X times x squared is an x cubed. X times 9 is a 9x. 2 times x squared is a 2x squared. 2 times 9 is 18. It's totally not in order, so let's put it in order and make it look like a function. So we'll name it f of x equals, x cubed would go first because it's the highest degree, then the 2x squared, then the 9x, and then the 18. And there it is, working backwards. Really not bad at all. Okay. All right, so let's look at number 6. N equals 4. So that means that this is the degree. It's a 4th degree, so that means there should be 4 solutions, 4 zeros. Okay, I see 1, 2, 3, but then it also says that this one is a double root. I want you guys to highlight that. Double root means that it happens twice. We also call that multiplicity. So sometimes they'll say x equals negative 4 multiplicity 2. Same thing as calling it a double root. Okay, so what that means is when you have a double root, that means, okay, we have one of the roots is x equals 2, one of them is x equals negative 5, and 2 of them are x equals negative 4. So x equals negative 4 and x equals negative 4. It occurs twice. That's all that means. It's really easy to remember. Okay, so let's unsolve these. So to unsolve x equals 2, it would be x minus 2 equals 0. To unsolve x equals negative 5, it'll be x plus 5 equals 0. Then x plus 4 equals 0, and again x plus 4 equals 0 because that was a double root. All right, now that we know what the factors are, we can write those factors next to each other. So x minus 2, x plus 5, x plus 4, and another x plus 4. Now, because there's no i's, it doesn't matter which two you're going to multiply at the same time. So because that doesn't matter, I like to start from left to right. And you can only multiply two at a time. So I'm going to multiply the first two together first. X times x is x squared. X times 5 is 5x. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. And then I clean it up first before I multiply in another one. So I will have x squared plus 3x minus 10 times x plus 4 times x plus 4. Okay. Now, I want to choose the next two to multiply together, and I am going to be strategic. I could multiply this trinomial times the binomial, but I kind of want to just multiply these two together. So let's do that. So x times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. Oh, I got to simplify that. So x squared plus 8x plus 16 after we combine like terms. All right, bring down this one. X squared plus 3x minus 10. And we got to FOIL that bad boy out. That's going to take some foiling. Here's a good way to organize everything when you're foiling something like this. Let me show you. So x squared times x squared is x to the fourth. X squared times 8x is a positive 8x cubed. X squared times 16 is a positive 16x squared. Now I have to start with the 3x. 3x times x squared is a 3x cubed. And I'm going to write it underneath the x cubed term I already have to kind of group them together. 3x plus 8x is a 24x squared. And notice I'm grouping it with the x squareds. And then 3x times 16 is a positive 48x. Let me just double check that. 3 times 16. 48. Good. All right. And now the last term, negative 10 times x squared is a negative 10x squared, and I'm grouping it with the x squareds. Negative 10 times 8x is a negative 80x, and negative 10 times 16 is a negative 160. So now I can just combine straight down. X to the fourth had nothing to combine with. 8x cubed plus 3x cubed is 11x cubed. 16x squared plus 24x squared minus 10x squared. Well, let's see, that's 6 plus 4 is 10. Carry the 1, 2, 3, 4. So that's 40x squared minus 10x squared is a 30x squared. 48x minus 80 is negative 32. So negative 32x. And then minus 160. So let's slap an f of x in front of it and call it a day. There we go. Can even use that as my box. And there it is. There's my fourth degree polynomial. Lots of multiplying, lots of distributing, but it's doable. Okay, number 7. The degree is 3. So that means that we should have 3 zeros. I see 1, 2. So remember, this one has an I in it, and I's come in pairs, so the third one must be the 4 minus I. It's complex conjugate. So let's write them out. We have x equals negative 1. We have x equals 4 plus I. And I have x equals 4 minus I. Okay, and let's unsolve each of these. So to unsolve the first one, it would be x plus 1 equals 0. To unsolve this, I would have to subtract 4 and subtract I. So x minus 4 minus I equals 0. And then for this one, I would have to subtract 4 and add I. So x minus 4 plus I equals 0. So now I know what the factors are. Factor of x plus 1, a factor of x minus 4 minus I, and a factor of x minus 4 plus I. Okay, and I just got to multiply them together. So 2 at a time, but remember, because we have i's, we have to multiply the I factors together first. multiply the i's first. Exclamation. Okay, so x times x is x squared. X times negative 4 is negative 4x. X times I is an ix. Then negative 4 times x is a negative 4x. Negative 4 times negative 4 is a positive 16. That didn't have anything to group with, so I'm just writing it over here. Negative 4 times I is a negative 4i. Then negative I times x is a negative ix. Negative I times negative 4 is a positive 4i. And negative I times positive I is a negative I squared. Yeah, there's some gaps in there, but that's okay. So x squared is the highest degree. Negative 4x minus 4x is negative 8x. Ix and negative ix, these cancel. And then I have a plus 16. Negative 4i and positive 4i cancel. And I squared, we know, equals negative 1. But a negative times a negative is positive, so that's a plus 1. So this is really x squared minus 8x plus 17. Okay, so there's that. Now we can bring down that last factor of x plus 1 and multiply it in. So we'll have x times x is an x cubed. X times negative 8x is a negative 8x squared. X times 17 is a 17x. 1 times x is an x squared. 1 times negative 8x is a negative 8x. 1 times 17 is 17. So we'll call it f of x equals, the highest degree is the x cubed. And then I have a negative 8x squared and a positive x squared. Those are like terms. Negative 8 plus 1 is negative 7x squared. And then 17x minus 8x is a positive 9x. And then plus 17. And there it is. Now we have the function. So they're not really hard, they're just lengthy. These are kind of long problems. Lots of algebra involved. And that's everything. Have a good day, you guys.